Hi, everybody. So this is screencast number 2. This should be, it's not going to be very long. And I want to let you guys know that questions you need to answer along with this have the major air pollutants from screencast 1. I didn't want to make those questions super long, and acid rain is kind of small. So what I did was I added them onto this. So for that, the acronym is you need a nose clip, NOSCLP, which stands for those major air pollutants. Okay, so here we go. Screencast number 2, slides 24 to 30. So tonight or today or whenever, you're answering study guide questions 10 through 14 in the Google Sheets. All right. So acid deposition is acid coming down. You have dry deposition in wind. You have wet deposition in rain, mostly from hydrogen sulfide and nitrous oxides going up into the atmosphere. And you also have acid fog, which is bizarre. So if you look at this here, the red is these are the pH values. So anything under about a 5.5, 5.3, I have it written down here, is considered acid rain. All over the East Coast, we have acid rain because if you look in this area over here, this is your big, oh, wait. There we go. We're going to go red. Here, these are the Appalachians, and this is all big coal being produced. You look out here, this is, in the Pittsburgh area, that's big steel production. You have a lot of dirty coal burning power plants all in this Ohio Valley. So the Ohio Valley is all of this. This is Ohio. You go all the way down, paralleling the Appalachian Mountains. Our prevailing winds, as you guys know, oh, come on, come from the west and go towards the east. So a lot of the air pollution gets blown towards the East Coast, even though in New Jersey we do have a lot of like petrochemical industry and refineries and stuff like that. Okay, it just adds to it. So here you go. You can see on the bottom, if I can move this. There we go. You have the different pHs. So around us, you're about a 4.3. You go outside, it's not going to burn your skin. It's just, it can have other effects on the environment. So here you have areas in red, which are really bad. Lakes, rivers, things like that can become more acidic. Yellow areas are potential. And then you have areas with sensitive soil. So you're talking about rainforests, which you guys already know have crap soil. And then you're getting up here into the Pacific Northwest and Northeast. So these are areas when you start coming into almost like your temperate, those are your temperate rainforests on the west, not going up that far, where you have areas with crap soil to begin with. So here we go. Lower than 5.6 is considered acid rain, acid snow, acid dust, acid gas. Okay. The main acid is carbonic acid. Carbon dioxide mixes with water, carbonic acid. All of this sulfur, okay, from the burning of bituminous coal, high levels of sulfur. So you have nitric acid or sulfuric acid that are formed from sulfur dioxide and nitrogen dioxide, and that's our wind patterns running west to east. So we're kind of slammed with it on the East Coast. Haha, here's a fun thing. I'm going to put that up there. So acid rain can cause a lot of damage to the environment. There we go. So stage 1, the gas, I wonder if I can move myself. So the gaseous sulfur dioxide and nitrous oxides are produced during the combustion of fossil fuels. Traffic, factories, and power plants are sources of these pollutants. Sulfur dioxide, nitrogen monoxide, nitrogen dioxide coming out of cars. So sulfur dioxide and nitric oxides react with water vapor held in clouds. They form acid rain. Normal rain is slightly acidic, but acid rain has a pH lower than 5.6. Acid rain causes billions of dollars of damage to buildings in the US each year. Limestone, marble, and sandstone are especially vulnerable. These tend to have higher pHs. So they have a higher pH, so they have a higher buffering capacity. Okay. Antacids, when you have heartburn, stomach pain, it's because of too much acid. You have an antacid, which is like a calcium carbonate. That's what Tums are basically made up of. Okay. So buildup of acid rain deposits in lakes and rivers can kill animal and plant species. It has also been shown to increase the number of deformities in fish. In addition, the leaves on trees can be damaged by the acid rain, which then is a positive feedback loop for preventing photosynthesis. It dissolves and washes away essential nutrients stored in the soil. Remember when we were doing soils and we were doing soil testing, the pH was so important because you have nutrients that dissolve in water, then that water is taken in by the plant roots. And that's how these plants get their nutrients are from the soil, from the water in the soil. But the thing is if the pH is too high or too low, what ends up happening is those nutrients cannot dissolve in the water, and then the water that's taken up by the plants doesn't have all these nutrients in it. Okay. Acid rain is an international problem. It can fall hundreds of miles away from the source of the pollution. East Coast, we don't produce all of the acid that causes our acid rain or all the pollution that causes our acid rain. We get it from other areas as well. Pollution created by one country can damage another country. If you've listened to any of Cuomo's stuff, um, we're now working together as a collaboration of 7 states. It's Massachusetts, Rhode Island, Connecticut, New York, New Jersey, Pennsylvania, and Delaware. Okay. And what Cuomo loves saying is that the virus doesn't know our political boundaries. It doesn't know the state boundaries. So we all are acting together because it's it's pollution knows no boundaries. It doesn't get to New Jersey and it's like, oh, we're not allowed in there. We have to stop. Right. So, oh, I might have to exit out of this. Maybe. There we go. All right. So, nitric acid comes mainly from the burning of gasoline in vehicles. Sulfuric acid is from the burning of coal and power plants. And then you have more acid rain and more of this pollution concentrated around industrial areas and cities. There we go. So you can see this is a forest. It's somewhere in the northern part of Germany, and these trees have been decimated by acid rain over the years. You can see a lot of new growth underneath, so this forest is recovering. You have big coniferous forests that are lungs of the earth, not being able to grow because of acid rain. So acid rain issues contributes to respiratory diseases, leach toxic metals like lead and copper from pipes and drinking water, like we saw in Flint, we're seeing in Newark right now. Damages statues, buildings, metals, car finishes, limestone, and marble, especially. Decreases atmospheric visibility, and you can have a loss of fish populations. You have that happy medium that fish like. Below 4.5, usually you're getting a lot of dead stuff. Okay, think of your oxygen sag curve that we did. That was from pollution with dissolved oxygen. Same thing happens when it comes to fish. Here we go. So these are animals and where they will actually live. Okay, so here you have a pH of 7.5. Oh, go back all the way to 4. So at 4, up to 6, you're going to have crustaceans, snails, mollusks. Okay, perch, pike, brown trout. Those can live in more acidic conditions. Eel and brook trout, same thing. Insensitive insects will survive longer. When we're looking at bottom dwellers, remember when we did that lab? Certain fish are going to be indicators, and benthic macroinvertebrates definitely are going to be certain indicators of good or bad water quality, and pH plays into that a lot. All right, that's all I got for you guys today. Keep staying inside, 6 feet away from each other, cover your face when you go outside, and get through this. All right.